Alright guys, back again. Now continue. Now setup is done, so we can continue now. But right, so we were discussing this, and this is the input. Copy, paste. Right, this is the input here. So node 1 is connected. Wait a minute. So this is 0 index also. So this is 0. Wait a minute. Like this. This is 0. This is 1, 2, and 3 and 4. 3 is connected to 2 and 4 is connected to 2, right? Because this is bidirectional here. Yes, these are bidirectional, so if 1 is connected to 2, then 2 is connected to 1 also. So if we start with 0 index, then we visit immediate neighbors, and when first we push 0, then pop, push 1 and 2, pop 1, push 2, no, already there, pop 2, push now 3 and 4, pop 3 and pop 4. This is the queue. So let's code this first. Now code this, guys. Like, right, we got the size, we have adjacency list also. So we need a vector to mark widgeted. Alright, we can initialize this with false, and we also need a queue which could be maximized with size of n, so we don't need to initialize that. Just now we push the first element in this, which is first node, which is 0, I think. Push 0 and mark it as visited. Now while queue is not empty, we can push the neighbor elements in this. First we have to pop that, and now because pop, we have to keep track of this first. Now what we will do is q.front, that will get us. So let's go for this. We have in the queue we have 0 in the queue. Now we pop this, then we pop it, then q dot pop, then we go for its neighbors. For neighbors, let's say neighbor of what, u, which has been popped. Then go for, if neighbor is not visited, neighbors, then we go for push it, q dot push into q and mark it visited also. So what it will do, like, first it will go for adjacency of 0, which is 1 and 2, first it go for 1. If 1 is visited, this is visited. 1 is not visited, it will go for we push it, then it will go for 2. Is 2 visited? No, 2 will visited and pushed into the queue. Alright, then this one iteration is done. Now it will go again, pop this 1 and go for one's neighbors. One neighbor is 2, which is already visited, so it will this run for this loop for node 1 is done. Now we pop 2 and 2's neighbors is what? 0 is already visited, we will not push it. 1 is already visited, we will not push it. 3 is not visited, we push 3, and 4 is not visited, we push 4. Alright, then mark them also visited, and we go for 3, pop 3 already visited all the neighbors, and 4 already visited. And when we pop this, we can store this also in a answer vector, and we can return that vector. Alright, right. So what is this asking in the return type here? This is asking for a vector. Alright, so DFS order. So we can do this also. Let's say this is a vector answer, vector integer answer, and when we pop any element, we can push into that answer dot push value, and we can return answer also, where here return answer. Let's check if it is correct or not. Where is the error, guys? Is into u q front. Front spelling is, this is spelling mistake, guys. Alright, this is now like this. Compile and run. Okay, so running. Let's see. Alright, all test cases passed. Let's move to next question. Which is next question? Next question. DFS done. DFS of the graph. Alright. These are easy questions, so don't worry, guys. We will go to medium, then we will go to hard also. Let me get some water for me, then I will come back. Keep waiting. Let's wait 2 minutes. Alright, I'm back guys. So let's do this also. So DFS, what it do? Is this indirect graph or? So let's. Should we read the theory first? Alright, then we will do the question. Right? Is this good? Alright, so we can read the theory first. Alright, it will be convenient for you also. It will be helpful for me and you both. In DFS of our graph, we traverse all the adjacent vertices one by one. When we traverse an adjacent vertex, we completely finish the traversal of all reachable through that adjacent vertex. This is similar to DFS tree traversal, where we first completely traverse the left subtree, then move to the right subtree. And key difference is that unlike tree graphs may certain cycle too. Alright, unlike tree graph may contain cycle here. Alright, a node may be visited more than once. May be visited. Alright, but alright. To avoid processing a node multiple times, we use a Boolean visited array. Alright. There can be multiple TFS traversal of a graph according to the order in which we pick adjacent vertices. Here we pick vertices as per insertion order. Alright. Here right, control C here, control V of control C, control V. Right, this is the node, and what we are doing here is, so we are doing DFS on this. So we can change the color. Where are the colors? Color, what the hell, bro? Huh? Laser pointer. What? Web embedded. This is good. What more? What the heck? No, these are frames here. What do you do with the frame? No use. Colors, alright. Alright, we can choose color here. Alright. When we choose this, we can choose this shade. Alright, good. Right, we can choose this shade. Let's focus on not colors. The explanation first. Wait a minute. Selection. You can delete frame also. Right. Now we have our zero zero node connected to 1 and 2, and the 1 is connected to 0 2, like vice versa. 2 is connected to these, 3 and 4 is connected to 2 only. So what this DFS is doing, we can blah 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 blah. But this is not going our way. Alright, what is this saying? It is saying like, alright. Let me explain this to you guys. Let's forget about it. What is this saying? That we go in the depth of one analogy is good here. Like we first for every node we first traverse this leftmost node first, then right, then return all that. So what we are doing is 0. Let's say we start from 0 node. We go, there is no left or right here, right? So we can go here also, doesn't matter. So just forget that. What we do, we first, if we are accessing of any child, traversing any child, we first traverse that child entirely for a particular node, right? Then we go for other child. Not like we first, and not like BFS, like we first traverse 1 and 2, then 0, 1 and 2, then child of 1 which is already visited, child of 2 like 3 and 4, then we go for that. This is not like that. This is like we go for 0 to 1, then traverse all 1, then 1 to 2, traverse all 2 which is 3 and 4, 1 is already which is 3, all the 3, like we go 0, then we go for, let's say we traverse 0 child 1, right? So we will not traverse 2 here, alright? We go inside 1 and traverse 1 entirely. So 1, how to traverse entirely 1? 1 has two neighbors, so which is 0, which is already visited, and its a parent also, we cannot go there. So we should not visit 0 multiple times also, and we can get into infinite loop like that. So we go for 2 child, we go for 2. Now before going to anywhere else, 2 or 1, we go for 2 childs, and we take 3 here, and we go for 3, there is no child here, so we return. Now we have to traverse 2 entirely, so we go for another child which is 0, which is already visited, we can't go there, which is another is 1, already visited, no, we can't go there, we can go here. So 2 is here, so 4, we visit 4, we go for any child, there is no child, we return, we already return from here, we return here, and 0, we check for another child of 0 which is 2, now it is 2 is already visited, so we return from here also. So this is the sequence we have visited. So let's code here first, alright? We can try it on where GFG, where is the link? Can we try it anywhere? We can solve that. No? Why not? Why not, guys? DFS, try it on, practice it on. Can we do that? No? So we have the link in here also. We have the link in here to practice it. BFS 1. Where is the practice link one? What the hell, guys? What the hell? So wait, interview questions. Well, practice bro. We can go for DFS Sophia, alright. Can you practice anywhere? Alright, we can code here, right? We can code this here. So we have given a connected and direct graph. So graph can be undirected or disconnected also. So we can do this also, guys. So because this is connected, we can solve this for right. So this is explanation for connected. So we can do this first, then we go anywhere else. Wait a minute. Right. First we have a adjacency list. Alright, and we can count the how many nodes are there, which is a digit of size. Now we have number of vertices. We create a visited array. Visited. We initialize it with false first, because no node is visited yet, and then we go for a DFS function, which is like so. First we are this is a direct connected graph. So what we do is DFS. We are starting from 0 index and 0 vertex. Then we are giving a DJ here, and we are passing visited. Now define our. We have a answer also. Answer, which is a vector, and answer. Alright. We can pass this also with this. Right. So what we do is we will find DFS and index, and we have vector, adjacency list. We have a vector of Boolean, visited, and we have a vector of integer, answer, and right. G. What happened? Right. Guys, what just happened? Right, so there is also DFS function which is alright. So we can't name two functions like that. So we can do is DDFS. Alright, it is what depth of first. Wait a minute, guys. What we are doing here? But we are getting answer here. Alright. We are doing it now, right? So first visit this index is equal to true, because now 0 is visited. Now we check for its neighbors. So go for neighbor here. for any we can post it also in the answer, alright? True, and we can post it in the answer. Is it should we post it in the answer, right? Wait a minute. Right, we can post it also. 0, 1, 2, 3, alright. For push back IDX. And we can check for this neighbors. ADJ of IDX. If not visited, neighbor is not visited, then we call for that DDFS for any I, and we pass ADJ, we pass visited, we pass answer also, and return. It will check for 1. It is not visited post, then it will check for childs of neighbors of 1. With 0 visited, we will not go here. 2 is not visited, we go here, right? Like, wait a minute. Right? Wait a minute. We can take again here, right? So we go for 0 first. 0 is not visited, we visit it, and we go for neighbors of 1. We first go for 1, and when it's not visited, we mark it. We go for all neighbors for that. We go for neighbors of 1 and 1. 0 is visited. Then we go for 2. We go for neighbors of 2. 3 is not visited. We go for 3 neighbors. There is no neighbor, so we return. Mark it visited, and mark it now visited. Return. Already visited, return, visited already, return, this is already visited, so our answer is there. First we answer post back 0, then 1, then 2, then 3 and 4. This will be the answer hour. So we can return that answer also. It's asking answer we have. Return answer. Let's check. First case is running. Let's check all the cases. Alright, all cases are running now. Good. So, where we should go now from here? Right. Next problem. Number of islands. So you can try it on the where GF is there. Can we try it somewhere, guys? Wait a minute. Can we go and try it? No. Alright, this is given. This is given. Alright, try it on GFG, right? We just missed it, right? Like this and like this. Right, there is. We can try it on GFG. So we read theory, alright? So what we are given, guys, here? Given a grade of size, wait a minute. We have a grade of size n cross m, alright? N is the number of rows and m is the number of columns in the grid, alright. Considering W is water, L is land, alright. Find the number of islands. So what is the definition of island here? An island is either surrounded by water or the boundary of the grid, alright. And is formed by connecting adjacent lands horizontally or vertically and diagonally, and alright, or diagonally also, right? In all directions. Then what? We have written number of islands here, alright? Alright, return what? Constants, what is output 2, alright. So let's take this example. Let's take this example and let's see explain this like land. Alright, so this is at the boundary, so this land is at the boundary, so this can be island here. This is this could be island. So if it is a land at the boundary, and so we can't count plus one, and we add the we reach for this all the connected lands. So this is also connected. This is vertically connected. This is diagonally connected. So this is one island here. Alright, we could have started from here also. We could have started from here also. This will form one island. Alright. Then again we go for here water. We again find land. Alright, we find land here, right? And all the sides are water, and this is land. This is one island. This is also one island. This is also one island. Alright, these are 4 islands here. So how to approach this problem? So should we start do with this DFS to reach all the immediate neighbors, or we should go DFS or BFS? So I think BFS is good because it goes level by level and give a sorted path and give the nearest neighbors first. Alright, we can go with BFS. Alright, so how many directions we can go? We can go up these are 4, 5, 6, 7, 8. So let's say we are at I comma j cell. We can go I comma j plus 1. We can go right. Wait a minute. We are on I comma j cell. We can go I comma j plus 1, I comma j minus 1. We can go I minus 1 comma j, I plus 1 comma j. Right. We can go. What is this? I minus 1. Right. J plus 1. I minus 1, j minus 1. This is I plus 1, j minus 1. This is I plus 1, comma j plus 1. These are the 8 directions we can go. Alright. So when we are at a particular cell, we can go anywhere in these 8 directions. So if any of the directions is land, if it is land, if any of the its neighbors is land, we mark it as visited. Is it correct? And we include in this island only. Then we cannot go from here, and we post it in the queue also. We have to check the neighbors of this cell also, because if it could also have connected with another cells, and this is also connected with another cells. This is also alright. So what we can do, guys, is we will first check for the one. Alright, so it could have without the boundary, it could have with the water also. Alright, so if it is boundary, if it is a boundary, alright, let's say we can tackle boundary nodes like that. Alright, and that's it. But what if all around the water, and this is let's say what to say? Wait a minute. Let's say we have land here and water and water here. So this is the boundary. This is water, we can go here. No, this is water. We are at here, land, water. if we encounter first land, we can go plus plus. So there is no boundary case here. Alright. So what could be our algorithm? We start from this node. If it is water, we go next. If it is water, we go next. Water, we go next. Alright. If it is land, we go for its neighbors, like. Right. So if it is water, we go for next node immediately. We don't check for neighbors for the right. But it's why we check neighbors? Because this is not in the island, right? If it is land, then it's going to be land, right? This is land. So we go here first. No, this is water. We go to the next. This is water. Next, this is water. This is water also. This is land. Now we go for neighbors to mark them visited like that. All right. And we have to check VFS also. Alright, we can do this. We can do this, guys. We have given a grid. We can check how many rows in this. So int m is equal to grid dot size, and then is equal to grid dot 0 dot size. Alright. Grid 0 dot size. So in this we can go like we have m and end. We can, alright, we can start from, we should have some direction. Alright. One more thing, guys, is to check the neighbors, we should have some vector int direction row column. Alright, we have row +1. We have 8 directions, no? So let's say we are at I, j. We go here, 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 and here. Let's say 1, 2, 3, 4, 6, 7, 8. To get at 1, what we have to do? We have to decrease one row, -1, alright. To get at 2, we have to decrease -1, alright. To get 3, we have to decrease -1, alright. To go on the 4, we to 0. Go on the 5, we have 1 row. Go to 6 is 1, 7 is 1, 8 is 0. Alright. We have another vector which changes on columns. So when it is -1, column is also -1. When it is 2, column is 0, I think here. Yes, and it is 3, column is 1 here. It is 4, column is 1 here. 5, column is 1 here. 6, column is 0. 7 is -1. 8 is -1. Alright. These are our directs to visit neighbors. We have some indexes to check. Now we have a queue also, QUE of pairs, because it has to store pair of indexes I and j. This is Q, and we can insert 0, 0 in this key dot push. First we have some vector of vector of grid. We have to make the grid right. We have to vector boolean, which is visited, and we have n comma vector bool n comma false. Right, now we can push the q dot push first, because it is 0 indexed, I think, right? Array 0 indexed generally, but I don't know how it is going. 0 indexed generally, so we go for like this. Node pair 0 comma 0. Alright, now visited, we can mark this visited also. Visited 0 comma 0 is equal to visited. So we can count also, and count count plus count is equal to 0. We can count the number of islands. Now while we can allow BFS while Q is not empty, and we can have I comma j here, Q dot front, or we can R comma C here, Q dot front, and Q dot pop also. You popped out of there. So let's say we are at something like this. We are at right. Wait a minute. Right, we are at like this here. We are at, let's say we are at here, because we can't have to, like, we are at here, right? We are here, right? 0 0 is this. We can say this. 0 0 is this. So we have, if it is water, we have to skip it. Alright. So it should be not visited. It should be not be water. Then we have to make it. We have to push it in the queue, right? So here. All the we have to go its neighbors. If right, so So it should not be like, if it is water, then what do we do? It is water, only L here. Then go water. No, we cannot do that. We have to keep track of the L's first, right? Because yes. So right, we can go for like this. Alright, so we don't need to do this here, alright? we don't need to do that here. We can check a for loop, right? If it's a for loop, it's a grid given, we can do it like for int I is equal to 0, I is less than m, I plus plus, for int I is equal to 0, j is less than m, j plus plus. Now we can go like this. Right, count is 0 here, count should be up there. Alright. If grid I comma j is equal to L and not visited I comma j, then we push it q dot push comma j here. Wait a minute. Alright, and we mark it also visited. Alright, visited I comma j equal to true. Right, so if we have water, then we will not go in the while loop also. Q dot push, then we alright, LQ is not empty, then Q dot if it is alright, R comma C front, Q dot push, alright. Now what we do? We go for neighbors because visited Q is only non-empty when we have L and it was not visited, and now it's marked visited. We are here. Let's say it's visited and we have pushed it I comma 0 and the we have to go to all the neighbors for this. So we move for loop for and I inside, so equal to 0, I less than 8 because there are I directions, I plus plus, and we have a new row which is DRI. We have a new column also because DCI. Alright, if it is out of boundary, so if new check for boundary, new r is greater than equal to 0 and new r is less than m and new c is greater than equal to 0 and new c is less than n, and it is not visited, and visited of new r comma new c should be false, and one more thing is it should not be L, not visited, and it should be L. Alright, visited, no. Grid I new r comma new c is equal to L, then we go for only q dot push new r comma new c, and visited also we can mark it new r comma new c is equal to true. Alright, so when we should count plus plus, right? So when we encounter firstly here, right? We can here maybe the count plus plus because right. So I comma j it will mark it visited, it will then mark it visited. For this neighbor q, this will mark visited. Now all of them cannot reach. Now q is empty again. Then we go for here. All right, there is no water. You go here, push it, count plus plus, push it, count plus plus. Well, I think this works. This should work, guys. All right, this should work. What the function is asking? Count. Number of count 0, I think. All right. Compile and run here. Case 1 4. Our answer is expected 1 or your output is 4. All right. What was the grade? All right. Let me check. Let me check what was that. N in M. Alright, N in M are there. N are there, M are there. Alright. So what was the hell? There is nothing. What the fuck is L? No L. W. Wait a minute. W L L W and L L L W. So there are n is equal to 4, m is equal to 2. Alright, so there is one element, only one element. Output should be 4. Output, what should be the output? Alright, this one element only. How it's working, our code, how it's code working. Our code is working, guys. M is there, grade 0 size, and is there, alright, there is no thing. And so we can go there, rows, right. Not visited, no. तो ठीक है, not visited. Alright, so we are not doing this. Alright. I think R plus here, guys. C plus. Now we can do this. We are not going in the directions here. Alright, now case is passed. Submit. We were not changing the cell. Right. This problem is done, guys. Next, go to the next problem now. Bipartite graph. All right, we can do that. Detect cycles and direct graph. Right. Delete. Right, done. So how to detect cycle and indirect graph? This is, wait a minute. We will discuss it also. Are we serious on the screen, guys?
So we can
This.
now do this GFG. We can write thread
Wait. Yes, we are sharing our screen. Good.
हेलो दोस्तों, इस वीडियो में मैं आपको काफी इंटरेस्टिंग न्यूज़ देने वाला हूँ, तो कृपया इस वीडियो को लास्ट तक जरूर देखते रहना। सबसे पहली जो न्यूज़ आ रही है वो आ रही है एपीवी की तरफ से। एपीवी का जो ट्रैक मेरा नाम है, इसमें आप देख सकते हो यूट्यूब पर 6 लाख से ज़्यादा व्यूज़ क्रॉस कर दिया है। इस ट्रैक का आप देख सकते हो एज वेल एपीवी कमेंट किया हुआ है, जिसको एपीवी ने लाइक भी किया हुआ है। साथ ही एपीवी ने क्या अपनी ट्रैक का अनाउंसमेंट कर दिया हुआ है। आप देख सकते हो अपने कमेंट को बताते हैं पत्थर लाला तैयार। आपको पता होगा कि उनका पत्थर लाला वाला जो टीम है उनकी लाइफ में लोग कितना वायरल है। तो पत्थर लाला उनकी कृष्णा के लिए बोला हुआ था, तो इस ट्रैक में क्या होने वाला है आपको लगता है कि जरूर बताना। साथ ही
guys, welcome back. I was just taking rest. I will do this question first, then I will go for my lunch, then we will continue after that. Alright. Are we back? Back. OBS is running. Still black. Right, are we starting? So we have to detect cycle. Wait a minute. Hello, what the hell? Right, so we will do this question, then I will go for lunch, then we continue after that. So question is detect cycle in a direct graph. So how can we detect that? Alright, let's see. So let's say we are using DFS. We can do this with BFS also, I think. Yes, that's DFS is very fast and easy. So let's say we are going here, right? Right. So let's say we start from zero. And we go for the child here, then we go 2 here, then 3, then 2. Right, backtrack, there is no unvisited. Alright, so what we check first, we are at 0, parent of 0 is -1, we have to keep track of the parent here, because cycle is when, let's say, so 1 and 2 are parents. Alright. When we are visiting 2 neighbors, we detect 1. But this is 1 is 2's parents in DFS tree. Alright. 0 then 1 we are trying, right? So then after 1 we are trying to. Now 2 is a parent. 1 is parent of 2. So we cannot make it like it is the cycle here. So this should be not a parent. Then 3. 3 and we detect there is no neighbors for 3 and we detect 2 is the neighbor but it is visited and the parent, so there is no sign of cycle here. Then go for 2, 2 has a neighbor which is 0 and 1, 1 is already visited, it is also parent of this, but 0 is the neighbor and visited and already visited and this is not the parent, so this indicates the cycle here. So this is how we indicate cycles. If we have a if there is a neighbor of any node which is already visited and not the parent of that node, then there is a cycle. So we can do that. Yes, I think we can do this. Using BFS, using DFS, first we will do DFS, then we do BFS also. Alright. Where is the what the hell? Where to guys, where to do this? We have to practice it, guys. I don't know. We can do it anywhere, alright? Search the problem. To degrade I will do delta. It is second direct graph using BFS tutorial. No, we don't need tutorials. If we know practice, alright, we know practice, then we have to practice it. Alright, we can. I have done this, but I will do this again for you guys. Let's reset code. We have number of we have given edges, alright. So we have given edges, we have to convert it into a edges list. So for convenience, because we use n for, we need to convert it into a, we have given edges, we have to make it a address list. Alright, adj of n. Alright, 0 is less than I plus plus right. How many pages? Right, so left we have to go for edges, alright. So we will not, we have to visit edges now for in the edges edges and u is what as 0 and is equal to is 1. Now we have to make the address list for that, which is ju wait push back v and it is a v push back u wallet. Because of the because it is indirect, this will be both sides. We have AdSense list here now. Now it could be indirect unconnected also. Undirected connected is indirect graph. It could be disconnected also. So we have to consider that possibility also. So and come false. So let's go for 0 is greater than like if I is not visited, then we call for DFS, and parent of this initial would be -1, so we go for I and -1 parent, and this list and visited also. Cycle would be true false, alright. Right, so if DFS returns true, we will detect a cycle, then return true here also, right, and we go for BFS for bool DFS and I parent and vector and adjacency. We have vector of boolean which is visited. Right, and we mark visited of I equal to true here. Then we may check for neighbors for any true I. Maybe for if not visited neighbor, then we go for DFS again for this, which is I, parent of it is I, and visited. If it is already visited, then else if parent is not equal to neighbors, then return true here, else we will return false. And we return false here. Right. Case 1 is right. Let's check all the cases. First case is passed. Wrong answer it, alright. 0 wrong answer. Wait a minute. If not visited I and is full. Right. If not visited I, then DFS. Visited. Right. Then what? So NVN. UVVU, alright, it's good. Here, visited true. Now you can submit this. So now answer 6 case pass already. True is correct, output is false, alright. This is a direct graph, no. And visited neighbor is visited and not equal to parent. When return true, we can submit this also here. How many cases for 600? Alright. Why is this so long? What is the problem in this, guys? What is the problem? I don't see any problem here. Not here, not here. What code is not working? Let's see. For input this. 4 nodes 0, 1, 2 and 3 edges are into 1, 2, 2, 3. Right, so this is visited. There is no neighbor for this. Now 1 visited, neighbor for 2 visited. 2 neighbors. Wait a minute. Right. So neighbor 1 is 2. What is this? Neighbor 2 is 1 here. So parent is 1 of 2. So right. Neighbor is parent. Not visited. Three neighbors of 3 neighbors. What is the problem, guys? Components, so let's check here. right? So here it, yeah, I now remember, like so you know. Well, then I was also doing that. I am doing this, so I am doing this, what are you suggesting? Here. Yeah. Alright, fine. If DFS is doing this, then return true also. No. We can do this also. Now we can move this. Right. Well and run. This will be pass. Yes. Ramaza for what? On the hand. So we can do else here, no? Now start. Right, we can do this. Some estimates sometimes. We can do this also with BFS, but we can do this with BFS also. Let's do this with BFS, right, guys? Alright, this was the initial condition. How can we do this? Because let's say we are at 0 and the Q is 0 here, and we pop it, we post 1 and 2 here, and we go for 1 here, right? We go stress 2 already there, we go for 3, to never is any I, and how to give parent here, so we have to right. Neighbors are 1 and 0 here. 1 is a parent, but 0 is not a parent, right? So we can keep track of parent here also. So, but we have to make a data structure here. Parent. You have to give the phone right visited. Alright, we can do this also. Let's try this, guys. We don't need BFS right now. We have agency list. Visited is there, alright. We can push. We should have a queue element. We should have a queue. We should have a vector of boolean, no vector of print of parent comma -1, and we have q also, q e u e integers q dot push 0, and we make visited also, make this visited to 0 as true. Alright, now while Q is not empty, enter node equal to Q dot front, Q dot pop also. Now we check neighbors of all this, and for auto any DSA of node, if not visited here, if not visited any I, then what we do is Q dot push any I and make it visited. True parent of visited will be right, parent of any I is equal to which is node. Right, if it is already visited, else if this is visited and parent of any I is not equal to node, then below return true. Alright, else return false. Let me check this. This one is passed. We can comment this function, leave the function, right? We don't need this now. Alright, submit, we can submit this also. Is this handling all the pieces? This is not handling the disconnected graph is alright. And I is equal to 0, I is less than 10, I is plus. If not visited I, right, we can right, this is value right, so we can go this I here, for this I, alright, we can compare on here now. This is very visited. Where is wrong answer is coming from, bro? Every time it hurts. It hurts, guys. It was not empty. True. If it is not visited, alright. If it is not visited, then do this. If it is visited, if it is neighbor and it's visited and it's not parent is equal to node, then return true. Why not? Where are you lacking, bro? Hmm. Alright, this is like this, is it? And like this. I think it is good now. Well, we are checking parent. Hmm. Six, it's parent node. So, at what example it is not working, guys? I think it's my lunch time, guys. I will just quickly wrap up. I have to go for lunch. Where did you? Which is below? The whole is below, right? This below, right? We can do this here. Right. Right, compile and run. Let's submit this. Now it's done, guys. Thank you. We were not assembling this code, right? Thank you so much. I will now end this stream for a half hour, and